This week on Technado, we'll be talking about how some European network traffic was rerouted through China, how Don's camera was hacked, as well as an interview with John Prisco from QuantumXC. That's all coming up on Technado, starting right now. Hello and welcome to Technado. I'm your host, Peter Van Rysdam, joined as always by Mr. Don Pizzette, and not this week by Justin Dennison. We should have just left the chair here.
You know, this is the problem with bringing on new people.
Unreliable.
They think they can take vacation. Yeah.
The nerve.
From this unpaid position.
Wait, we're allowed vacation?
Well, it's not really a vacation. It's just like instead of being not paid to come and do the podcast, you're not paid to not come and do the podcast.
Yeah. Oh, yeah. Okay.
It works out.
It's good to know we have options. All right. Well, we do want to get into the news today. We've got a lot of security news and then some other fun stories to get to. We also have an interview coming up in a moment with John Prisco. He is the CEO and president of QuantumXC, and we're going to talk about all the fun stuff that they're doing that Don understands, luckily, so he'll be able to explain it to you more. But let's get to our first article over on zdnet.com. For 2 hours, a large chunk of European mobile traffic was rerouted through China. It was China Telecom, again, the same ISP accused of hijacking the vital internet backbone of Western countries. And so the big question, Don, is did this affect Snapchat for us at all? Or for Europe?
For Europe, maybe. If you were on a mobile device. So this one was a little more localized. And when I first saw this article, the things that run through your mind, you're like, this can't be the same thing again, can it? Oh, it is. Well, surely it'll be a different telecom. Oh, nope, same one. So it's like exactly the same. Last year, it was a big deal that for a period of time, it was a little bit longer last year, a number of networks, including networks used by the U.S. Pentagon, our military leadership, were being redirected through the Great Firewall of China, through one of China's ISPs. And at the time, it was described as a mistake, right? An incorrectly configured BGP advertisement, the Border Gateway Protocol that is how we find networks on the internet. BGP was built in a very trusting manner back in the 1980s when it was implemented, and it doesn't have a whole lot of features to actually verify whether somebody has a route they say they have. So if somebody advertises out a route that is actually tied to, say, networks here in the United States or the mobile networks in Europe, as is the case this week, they can say they have it even though they don't, and all the traffic gets routed to them. Now, that normally causes an outage, and that's the end of it. But in this case, everything that goes in and out of China is recorded. And let's be honest with ourselves here, everything going in and out of the United States is recorded too. So when you know the traffic is being stored and retained by a government that, well, I guess it's if your government's spying on you, it's okay. But if somebody else's government, then it's a problem. So
I pay our government to spy on us.
You know, that's a good point.
I don't pay China to spy on us.
Yeah, if we paid them, it would probably be okay.
Yeah.
Then, it'd
be
different.
We pay them through all the loans that they
give us, right?
Indirectly, I guess it all works out.
Yeah. Well, anyhow, either way, so irregardless, that's my word for the day. Or non-word.
Not so much a word, but yeah, we'll go with it.
A made-up word for the day.
So how do we track this and know that it's them? Because, you know, when I watch shows like 24 and those classic shows, you know, they're like, oh, they're bouncing the data all over the globe. And how do you know which one actually did it?
Yeah, so what usually happens is you'll notice performance decreases, right? So it takes longer for traffic to get somewhere because it's going, all the way to China and then back to wherever you were supposed to go. You as an end user, like if you're just a regular average Joe at home and you want to see how you get somewhere, there's a really cool program out there called MTR, which I believe stands for Mike's Traceroute. Like a guy named Mike wrote it. It's a traceroute utility, which any Linux, macOS, Windows machine has, but it has an extension you can use or a command line argument where you can actually see the BGP autonomous systems you pass through. And when you go to Facebook, when you go to CNN or whatever, you'll pass through a number of autonomous systems. And instead of going through the 4 to 7 that you normally go through, you'll see jumping all the way to China. You'll pass through like 8 or 9 just on the way there and another 8 or 9 on the way back. You'll see this massive path, and that's how you can tell your traffic's being directed somewhere. So it's all about the Border Gateway Protocol, BGP, and how it does its work.
All right, sounds good. I will make sure that I didn't. Well, I didn't send anything I shouldn't have last week. So
Yeah. Well, you weren't in Europe on a mobile
that's
network
true.
either, so
That's
you're
true.
fine.
Yeah, I'm good. But I'll be aware of the next one. That it
Always
gets
have to
me.
remember the scope of the attack, right?
That's true. That's true.
We shouldn't call it an attack because officially it is simply a mistake made by a telecom.
Do I have an attack on my buzzword bingo card? I don't. But
Good reminder, though, for
yeah,
the
I
viewers
should
at
let
home.
you know that if you're not playing Buzzword Bingo, you could be playing Buzzword Bingo with us if you just head over to go.itpro.tv/buzzword dash bingo. There we go. I said it. And we've actually updated a lot of the words to make them more common. We had some like, synergy and things that just weren't happening as much as we'd hoped. But
And we added our beautiful full color logo to the center free
We did,
square.
yeah.
So, I mean, that's an upgrade in and of itself.
that's huge. Yeah, I got to look back and see what you said there. All right, I'll do that while you're telling us about this embarrassing story for yourself. So, if you've watched the show before, you know that I have a Foscam camera at home, and if I'm sure you've watched the show I put on at home then, because it is apparently very easy to hack into my camera and watch my dog during the day as I do. But so now we've got an opportunity to turn the tables here on Don over at VPNmentor.com. A report, Theta 360 data breach leaks millions of private photographs. And Don, I see you walking around with the Theta 360 all the time.
You know, a lot of times you hear about these devices that get hacked, and they're cheap devices, inexpensive. I'm sure when you were doing your research to buy your Foscam, you know, the merits, the development cycle, and all of that were really important to you. But ultimately, the sub $50 price tag, you know, makes them really attractive. I had a Foscam as well,
and it's PTZ. That was what did it for me. I can one camera rather than two cameras with different angles.
And why Nest can't do that doesn't make any sense to me, but they don't. In this case, though, it's actually a pretty expensive device. You know, when we moved into this building, somebody around here, probably this guy, thought, boy, wouldn't it be fun to get out and film some 3D video so people could put on their VR headsets, because we all do that now, right? That's a regular part of our day. And be able to look around the building and go on a tour without actually being here. So I have one of these cameras. I do use it. I've used it as recently as last week. So this is a breach that affects me. And, you know, there's nothing I could have done in this case. Like if you had dual, triple, quadruple authentication or whatever, it doesn't matter. Up at the Ricoh servers, Ricoh is the company that owns Theta 360, the people known for making printers and color copiers.
Yeah, the Ricoh with an H, right?
Yes. Yeah. And they are not known for securing database servers. And in this case, not an attacker, but a security researcher found where they were able to access photos. And initially they were public photos, which you could have found anyway, so that wasn't really a big deal. But then they found by manipulating some of the search strings that they were able to actually gain access to videos marked as private, the hidden videos. And they were able to access people's 3D VR photos and videos all throughout the site. They reached out to Ricoh. The security exploit was actually patched within a matter of, it was between 2 and 3 days. It was really, really fast. They got it taken care of. And so the security researchers actually said, like, man, it was a great response from Ricoh. They got in there and took care of it. So that was nice. But it does highlight the fact that when you post things online through other companies, you are trusting them to secure that data.
So just to clarify, is the device itself a connected device, or did they breach the server, the site that you go to store the videos you take?
They breached the site that
Okay.
the store is on. Yeah, so the device itself is, I mean, it's off most of the time, but even when it's on, it uses your Wi-Fi network to either talk to an app on your phone or to talk to your desktop. And then your app or desktop will then send it up to Ricoh's servers. So if you weren't using Ricoh's servers, then you weren't really getting much out of the little device. But if you were, then that's where it got breached.
And so, second question, what is so exciting in your life after this building was built that we need to see it in 360?
Well, you know, so if you've ever been to the IT Pro TV studios, you know, we have 5 studios arranged in a circle. And my original vision was to just stick it right there in the middle and people could kind of see what was going on. And it's 360 degrees, so people could look around and see if they want to look at a particular studio. Never quite worked out, but one of these days I'll get it hung up. And they're probably when they stop supporting the device. That's when I'll get it hung up.
Perfect. All right. We said you used it last week.
I did, yeah. As I was testing the live streaming and
okay.
stuff. Yeah, not like a production use.
All right.
Not yet.
All right. Sounds good. All right, let's head over to slashdot.org now. Russia says it will soon begin blocking major VPNs. And I appreciate Russia for being upfront about it, as opposed to China, China didn't announce we're going to route all of the internet traffic in Europe's mobile networks
Just so you guys know.
through us. Yeah. But so what does this mean for us? That if you are in Russia using a VPN is when you'll have a problem, not that someone using a VPN in America or anywhere else would have problems accessing
Correct.
sites hosted in Russia.
Right. Yeah. And this all stems from about almost 2 years ago now when they passed a law in Russia that basically said if you're transmitting encrypted data, you have to submit a private key or a backdoor of some sort to the government so that they're able to monitor the communication. So you are not allowed to encrypt data in Russia. And I know that sounds like an extremist law. We've actually got a couple that are working their way through the House and the Senate here in the United States, too. So this is it's crazy that these laws exist, but they do. And the problem is there's a number of VPN companies that are outside of Russia, and anybody inside of Russia can sign up for one. They list like NordVPN and some of the other bigger ones that are out there.
Hide my ass. It's apparently a major VPN. I did not know that. I just wanted to say that.
We've interviewed them.
Really?
Yeah, because they were tied to, what was the Anonymous or whatever? They were tied to that. That was like
that was at RSA in the Sandbox.
Yeah, forever ago.
Yeah.
So they've been around a little while, or HMA as they professionally go by, because, hide my ass is not exactly what you put on a business card. But either way, so Russia has finally announced that, these laws are already in place. So if you're caught using one of these VPNs and the government doesn't have access and they need it, then you're going to jail. So now they're going to actively start blocking the connections to those VPNs. So if you were in the Soviet Union, one of the things that our U.S. State Department is saying right now, if you travel over to, I said Soviet Union, it's not the Soviet Union.
Yes.
So
it's been a little bit.
Yeah, if you travel to the good old CCCP.
If you have a time machine.
Yeah. So they tell you, don't take your cell phone, don't take your laptop, and so on. And a lot of people say, I'm going to go over there, I'm just going to use a VPN the whole time. Well, the odds are you're not going to be able to use a VPN while you're over there. So you just need to plan accordingly. Like, just know that the data you use is monitored. And you probably need to be honest with yourself and know that when you're here in the U.S., your data is being monitored as well. And anytime you use a network that you didn't pay for, then it's going to be monitored. That's how it works.
Well, it sounds like the workaround here is to use a minor VPN because Russia will begin blocking major VPNs, they said. So.
And, anybody can spin up like an AWS node and drop open anybody. There's little appliances. You can click a button.
I do it all the time.
DigitalOcean has that as well. So, you can drop a VPN server in one of these cloud providers. And so now it's not like your IP would be on a list. You just spontaneously create it and go. So this is a really hard one for them to stop. They're just going after the major targets.
Sounds good. All right. Well, let's go over now. We're going to come back domestically to the U.S. For us at Engadget.com. Hackers steal traveler photos and license plates from U.S. Customs. They took advantage of a subcontractor's mistake, but at the end of the day, you're responsible for your subcontractors. So so this means that if we're talking about license plates, these are probably people coming through a physical border, driving through Canada, Mexico, where they're tracking that stuff. And so the question is, do they have the data that goes with those photos to know who this was? And
right. And so as you were saying that, you said Canada, Mexico. I kind of felt like you were going to go to a third one. And so in my mind, I'm trying to think of what other physical borders do we have? It's just
the Bahamas when it freezes in the Caribbean and you can drive
over the ice bridge.
Yeah. Oh, Russia. Yeah.
Kamchatka, right?
It's the ice bridge. Yeah.
Uzbekistan. What is it? It's not a geography podcast, but
clearly, the Soviet Union came up in the
when we
last
play
part.
Risk. It's Kamchatka that's over there on the side, right? That's
the Ukraine is weak.
So either way, it is our physical borders, Canada, Mexico. They did capture license plates, and this is where I always get into that argument of what really counts as PII these days, because anybody in our parking lot can see my license plate number. It's on the outside of my car, so I really expect that to be private.
You drive with yours on?
I flip it around like a Knight Rider.
Come on.
So, if somebody has that license plate, that doesn't really tell them anything about me. But if it's linked to photos, right? Because they do take pictures of the vehicles as driving by and the people that are inside it. If they get that, if there's enough there to piece that together, now they know exactly who has that car. In this case, it was an image server, so they were getting camera pictures, which means they don't necessarily have other IDs. Now, typically what we've seen with the U.S. government and early with even enterprises is that if hackers gain access to something like this, it takes the organizations a while to figure out what else the hackers were able to get to. So they may have gotten more, but as it stands right now, they're just kind of pictures. And we'll have to see whether or not they're able to turn that into something else. But they brought up something really neat in the article because they were talking about facial recognition, right? And you can do image searches based on a face and find more pictures of that person. And all of a sudden, you know who they are. Here's their license plate. If it was a rental car, that doesn't tell you much. But if it was their actual vehicle, it tells you what state they live in. And, there's a lot of information you could start to get from that.
And we learned from that Mona Lisa article the other week that we can use deep fake AI technology and recreate that person to say whatever we want them to say. So,
and if you created like an extremist video with somebody and threw it on social media, customs checks for that now, or the border ICE checks for that.
We talked about how you have to give social profiles last week.
Yeah,
and you just share the good ones.
So if I knew that you were going down to Juarez for the weekend, I could create some deepfake videos, throw them online, and then as you come back across the border, enjoy Guantanamo Bay.
Well, I will be in San Diego next week for DattoCon conference. We're going to an MSP show, and I was gonna go down and look at the wall there. So they've got that. That's where the wall goes into the fence. I don't know, goes into the water. So if I get on the wrong side of it, and you've done that, oh man, this is going to be a bad time.
It could be fun.
For you.
For everyone. We'll make some live coverage out of it. It'll be a good time.
Sure, yeah. Yeah, since it's a fence, you could film me through it.
It'll be like Howard Stern, where you send the intern or whatever off to do something borderline criminal, and
I appreciate that.
Everybody else enjoys it.
All right. Let's go over to Gizmodo now. A year later, U.S. government websites are still redirecting to hardcore porn, which seems like a mistake.
Well, honestly, I'm having a hard time seeing the problem here, right? Like, because,
as long as I can still file the forms I need to file.
And if I don't have to file the forms, like this is probably one of the best services coming out of the U.S. government these days.
That's a fair point. Now, is this because people let the domains lapse? But I wouldn't think so, because these are .gov domains that I can't buy as an individual.
So these are where they've not secured their sites against cross-site scripting attacks, or they've got some kind of redirect functionality built into their web pages. And the idea is that when you would type in their URL, you would then do a question mark and a variable that would specify a redirect to go somewhere else. Now, that stuff should be sanitized, so it only allows internal redirects, but they are allowing public ones. And security researchers found this years ago, right? Well, a year later, I suppose, is in the headline. So if I want to follow a proper timeline there. So at least a year ago, many of the sites were fixed, but many are not. And they have some great screenshots here.
I'd be careful bringing up those screenshots.
Not pictures. They're showing how they've made it into Google.
Yeah.
So, you've got healthfinder.gov, nyc.gov, ddc.wa.gov. I don't know what DDC is, but that's
WA, so it's Washington.
Mm-hmm. Yeah, these are mostly state.
Okay.
Yeah, but there were some federal, but they were fixed. And basically, these sites are allowing some kind of redirect, and that's why you're seeing these variables and things that are thrown in there. In the example on healthfinder.gov, they're using /API/outlink / blah, 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 right? And they've got a page built so that when you click on their site and you click a link and it's going somewhere else, it's supposed to display that screen that says, you're about to leave our site. Do you want to continue? But if these things can be overridden, you can make it say, you're about to go into the weekend without a date. Would you like to meet somebody?
Yeah.
And so that's what's happening. A lot of people, when they get an email and they have a link in there and they want to find out whether it's okay to click it, they'll float their mouse over it and you kind of see the domain. Well, if the domain is a government website, that should be pretty trustworthy.
Yeah.
But if you don't see the full URL, because sometimes they're really, really long, you might not see all the attack stuff at the end of the URL, and that's what attackers are taking advantage of here. I imagine since it's back in the press, these other sites will start to get fixed again, but it's definitely something to be careful with anytime you redirect on a web server.
The DDC is the Developmental Disabilities Council for Washington State. So
that's like insult to injury there, taking advantage of...
That's rude. All right. I think that does it for our security segment now, so we can take a breath. That's all the data that's been taken from us this week. And
it's depressing, but at the same time, we ended with hardcore porn, so at least we had a turnaround there. It was like a M. Night Shyamalan film. Twist ending.
Not the twist I expected from our tech podcast, but There we are. Let's go over to InfoWorld now, infoworld.com. Hadoop runs out of gas as big data customers, big data, mark it off on your buzzword
big
bingo.
buzzword.
As big data customers flee complexity and embrace the cloud, mark that off too, the Hadoop vendors are sputtering. Did you put this article in here specifically for buzzword bingo? I know you use Hadoop, right?
You know, actually,
the little parrot, right? Hadoop, the logo.
I thought it was an elephant. Now I gotta wonder, am I mixing up my logos? So actually, I put this one in here because I thought this stuff was kind of ridiculous. It is an elephant. Yeah, Apache Hadoop. It's a little yellow elephant. It's if we look at my laptop, I got the crazy little elephant pulled up there.
Oh yeah, okay.
That's the guy.
I know what I'm thinking of. Go on, I'll find it.
Yeah. All right. Well, either way, so if we were doing this podcast 365 days ago, or even 2 years ago, we'd be talking about how amazing Hadoop is and how ridiculous it would be if your company wasn't preparing to support big data, if you weren't focusing on databases and being able to do analytics across large data sets and so on. And Hadoop clusters were like the way to do it. So tons of people were jumping in there and starting to focus on it. I think this is kind of similar to blockchain, where a lot of people have realized, I'm going to say a million buzzwords. So people are realizing that while it is powerful technology and it's got a lot of promise, it's not right for everything. And so what happened is Hadoop started to grow. They started investing. They created commercial pathways for them to make revenue, and it hasn't really worked out so well for them. And so what we end up with now is Hadoop doing some pretty big layoffs. There were several companies, the commercial companies cited in the article are Cloudera, Hortonworks, and MapR, which work with MapReduce. Intel, they cited, invested $766 million into Cloudera. So this just shows like people were really a big deal, or really investing in this. Two of the big leaders actually ended up merging because they, independently were only able to do so well. And then MapR has actually been laying off pretty heavily. So companies are starting to kind of divest themselves from that. And we'll get a giant full page ad for what site is this? InfoWorld. There we go. Yeah. So anyhow, so Hadoop not doing so well. And what that means to you, the listener out there, if your company invested heavily in Hadoop, it's okay. It's not going anywhere. It's an open source project, right? It's a Apache Hadoop, so it's going to be around. But if you're relying on a commercial vendor, you need to be prepared. You need to have a contingency plan that says, all right, I've got this big data. Now my company's relying on it. We've got reports that are coming out of it. We're making forward-thinking decisions, 5-year plans. This is obviously an important thing. We need to be prepared to either shift that data to another host or run it locally if necessary, or whatever, to gain, to maintain access for it, because the commercial vendors are kind of reinventing themselves. And hopefully this all blows over and next year it's all stable again. But the biggest challenge with big data is it's big. So you're talking about people with terabytes of data, and that's hard to just move from place to place very easily. So start looking into that now. And if you are just starting an IT career and big data is exciting to you, you want to diversify a little bit, right? Because it may be that Hadoop makes a resurgence. We've seen that with things like Postgres, where it was, for all accounts, dead, and then all of a sudden it made this huge resurgence. So that does happen, but you want to make sure that you're insulated for it. So that's what's going on in the world of Hadoop.
Yeah, and I want to go ahead and admit that I'm embarrassed because I was confusing Hadoop with Haroopad.
Oh, Haroopad, the markdown editor.
And that has a
little bird.
Parrot-looking bird, a blue bird. And I looked at this whole article as that's what it was. Oh. And I was like, I don't know why we really care that much about this. Because I remember I told you, I was like, do we want to talk about this story?
And I said it was kind of important.
I said, well, I guess more people use this markup editor than I thought. So
we'll save that for our markup podcast that we do.
A whole different
or markdown. I screwed that up.
Markdown. I think I said it first. So. All right, let's head over now to Tom's Hardware. And I know this company, Intel. Intel makes strong Ethernet switch play with BareFoot Networks acquisition. So I've not heard of BareFoot Networks before. Is that someone that you've
So I've interviewed some of the people at BareFoot Networks, or if we haven't interviewed them, I've definitely talked to them because they've been around. What's going on is several people, several organizations realized really about 10 years ago, that our network switches hadn't really advanced in any way. No real exciting new features have been introduced in the layer 2 switch world in a while. Aside from speed increases, as they went from gigabit to 10 gig to 40 gig and now moving on, that there just hasn't been a lot of advancement. And where you used to have providers like Cisco, where their switches, their Catalyst switches, were significantly better than the competition, or the old base stacks, or what ended up getting bought by Bay Networks became, I kind of lose track on some of this, became somebody else, and then HP bought them. It all gets kind of wrapped up, but the switches were all the same. And so what BareFoot did is they said, look, what if we just don't worry about the switch hardware so much, because it's all the same everywhere, and instead create an operating system that you can dump onto a switch, and that is what is driving it. And so they started selling basically bare metal switches, and they had their own OS, but you could get OSs from other people. And this really kicked off the software-defined networking space, or SDN, which is like a super buzzword that we don't have on our card. Or we have like software-defined anything, I think is one of our buzzwords. But either way.
We have software as a service, or
we should add software-defined. Everything's software-defined these days. So they kind of were very instrumental in all of that growing, and it looks like Intel is stepping into it. Now, Intel has been making network adapters for a long, long time. The Intel Pro series, I've been using them since the 1990s, definitely. They've probably been around longer than that. They're great, especially in servers or high data rate environments. Well, they haven't made switches. And so now they've acquired BareFoot Networks, which puts them in place to do a couple of things. They could say, here's our Intel switch platform, and now they'll get better integration with their adapters and their software-defined networking. They could do their own hardware switches. They could do their own switch OS. There's a lot of different things. They could do both, right, and roll out that way. We'll have to see where it goes. But that's a pretty big deal. If you're involved in networking, you'll want to keep an eye on that one, because the other vendors, Juniper, Cisco, Extreme, Foundry, those guys, they're not really doing a whole heck of a lot new on the layer 2 side, except for automation integration with virtualized data centers or hybrid clouds. And I think we're going to see Intel jumping into that space pretty heavy.
Ooh, thank you for saying cloud for me. I said it earlier.
Oh, and I never
So everyone
did.
at home has it. But
well, there we go.
And to answer your question from earlier, Bay Networks was bought by Nortel.
Nortel, that's
for $7.2 billion.
And then Nortel went out of business, and they're
probably because they spent $7.2 billion.
Well, I will tell you, like Bay Networks, I loved their switches. I used to pick them all the time back, when they were a market leader, and then Nortel just kind of slowly died, and they became just a patent portfolio, and that was that.
All right, let's move over to abcnews.go.com. Researchers say Bitcoin's carbon footprint equals Las Vegas. So this one kind of, it stuck out to me because I'm thinking, oh, this is all happening on the web. Why could the carbon footprint be so big? Is it that much computing power that everyone is using as they're mining it, is what we're talking about here?
So about a year and a half ago, I think, Bitcoin finally crossed the threshold where the electricity bill to mine Bitcoin exceeded the value of Bitcoin. So, in other words, if you were running your PC, let's just say you took your computer at home, maybe you had a couple of graphics cards in there that you were using their GPUs to mine Bitcoin, right? Well, those graphics cards consume electricity. Your processor consumes electricity. They consume a lot. People were buying 1,000-watt power supplies and sticking them in their computers to do this stuff. Well, the electricity they consume when the CPUs are running at 100% or the GPUs are running and it's all being coordinated, the electricity costs money. And some people weren't factoring that in, and they were mining a Bitcoin. Like, I just mined this Bitcoin. It's worth $1,600 or $3,000. But then they spend $3,000 in their electric bill. It just wasn't worth it. And so the original founders of Bitcoin said, like, when that point hits, people will stop mining, right? And that'll just be the end of it. But that hasn't happened. And the reason is that many people that are doing Bitcoin mining are stealing their electricity, right? Every now and then you'll hear about a high school student that gets arrested, or a college lab operator that'll get arrested because they're Bitcoin mining at night. That, when the lab is not in use, they'll fire up Bitcoin mining on all the lab machines, thinking, oh yeah, this is free electricity. I can get in here and mine and generate a Bitcoin and I'll just take it. Nobody's using the computers. Who cares, right? But there is a real bill behind it. And what I thought was interesting here is they quantified it in this article, that we've heard this statement that it's just not worth it to mine Bitcoin anymore because of the cost. Well, here they're showing the actual damage that it well, it's not damage necessarily, but that the
impact,
carbon footprint of generating enough electricity to power the Bitcoin mining machines out there is actually more than or equal to what it takes to power Las Vegas any given day, all year long. That's what we're burning. So I think people really need to make a choice between, do they like fake money that can be used for committing anonymous crime?
I do.
Or do they like gambling and prostitution? Like, you got to pick.
That's good too. Yeah. Well, luckily I have the U.S. government's websites to fall back on, so I don't need the gambling and prostitution.
You don't have to choose.
Yeah, and that's free, right?
Free-ish for your taxpayer dollars.
Free-ish.
What's the carbon footprint of paying our taxes? Of H&R Block.
Yeah, I do it all online. I don't know. All right, let's head over now to Apple Insider. We had a lot of Apple news last week with WWDC. This one is Apple is using a custom connector for the SSD in the new MacBook Pro. So when we say a custom connector, we're talking about under the hood. This is not something I'm going to be having to get another dongle.
So I totally missed this, and kudos to the team at Apple Insider for having a sharp eye and looking at all the press photos and stuff that Apple released. Last week, Apple released their insanely priced Mac Pro. I mean, it starts at $6,000 and then goes up from there, but it's modular. It's designed to be upgraded, and you don't usually hear the word Mac used in the same sentence as upgradable, but now we do. Like, this is designed to be able to grow with you as your needs grow. That's awesome. And it's using video cards, or they're in MXP format, and a few other things that are designed to just be easy to swap out and change and have all that modularity. Well, at Apple Insider, they noticed in some of the screenshots, so I've got the one pulled up here where it shows the internal storage that's used on them. And if you look at those connectors, at first glance, it's pretty small storage. So it looks like an M2 card of some sort, or NVMe, the typical storage that we're using in systems these days. But that connector is not a standard connector, which means while it might be NVMe storage, it probably is, it's a custom connector. So it is upgradable, but you'll likely have to buy your upgrades directly from Apple, which means if you were hoping to buy just the base $6,000 model and then buy off-the-shelf components to upgrade your Mac Pro, there's going to be a few spots where that's not going to work out so well. Now, there are some standard ports to be found inside of the Mac Pro. There's they have a picture somewhere on the site. Here they go. Where there's some standard SATA connectors that are on the board that you can use. There's not many of them, but there are. So this may just be affecting the internal storage where the OS is installed, and your expandable storage might be able to go different. But if it isn't, and we won't really know until we get a good look at all this, it means that while it is upgradable, those upgrades are going to be pretty darn expensive. So don't plan on saving money by going with a Mac Pro.
Now, is this something, though, where people could still create third-party? I mean, you can buy a third-party Lightning connector, but that's an Apple product. I don't know how that trademark stuff works. I don't know if you do.
Well, so usually people will come and make adapters, but the adapters almost always affect performance in some way or another. With M2 cards, it's a little bit harder because if we look at the card, you've got the connector, and then there's a little screw bolt on the back side. So it's kind of connected on both ends. So you can't make it any longer than the form factor already is. Now, we can't see under the shielding to know, do the chips run all the way to the back? And if you buy an NVMe card, the chips normally run end to end. But if you had enough blank space to be able to fit an adapter in, maybe you could do that. If this is a truly proprietary connector, people won't be able to make it without licensing it through Apple. But an adapter doesn't have logic to it. You're usually just kind of like remapping pins, and that's something that you don't typically have to have a license for. We'll have to see how that plays out. But I suspect if you're spending $6,000 plus on a Mac Pro, then you're probably going to want to buy the official Apple parts just to maintain your Apple Care warranty and all of that. So it'll probably end up being a non-issue at the end of the day, but it's just another hidden cost kind of inside of this thing.
Sure. All right, well, let's end the news segment here on one more Apple article over at 9to5mac.com. $10,000 later, an Apple Store genius diagnoses a $0 MacBook Pro problem. And this guy, I mean, he could have bought a new Mac Pro and, 4/5 of another one or something.
So
with that money,
this story, it's pretty funny. Like if you read through it, it might be just a hair sensationalized, but mostly it's full of truth. And it's the story about a person who bought an Apple MacBook Pro, a fairly expensive one, right? Like they decked it out. I think they said it was $5,000 or $6,000.
Yeah, if he's a photographer, he's probably got a pretty beefy system.
And had a problem where it looked like the screen wasn't working, and had to make multiple trips to the Genius Bar. They replaced the motherboard twice. They replaced the screen. They kept doing all these different things. They finally ended up, basically replacing the entire MacBook. And then as they were looking at the old one, they found the problem, which was that the screen brightness was turned all the way down.
Oh, my God.
And apparently, if you run the hardware diagnostics on a Mac and you do all the other things, it never actually checks what your screen brightness is set to. And this one was effectively turned off. And so if the backlights are off on your screen, obviously you're not going to be able to see much, especially on the Retina screens where everything's so precise. That makes it really, really hard to see. But basically, the $10,000 number, he's counting like how much he would have billed if he was working during the time he was at the Genius Bar. That kind of stuff inflates the price a little bit. But it is funny that if you've ever made a dumb mistake like that, you're not the only one. And I'm not about to say that everybody working at Apple Store is an actual genius, but I just had a few weekends ago, we were replacing a firewall, and we had plugged all the cables in, and I wasn't able to ping the firewall. And what had happened was, it had Wake on LAN support on all of its interfaces, which is a weird thing to have in a firewall. But as you'd plug the adapters in, they would all have link lights. And in my mind, I had made the assumption the firewall was turned on, and it was turned off. And so I had to press the power button to fix that, and then tell everybody that was in the server room with me that they weren't allowed to tell that story, which I just told in the podcast.
Yeah.
But it just shows that everybody makes mistakes. And in this case, check your screen brightness. So,
well, how do you even change the brightness if your screen's off?
I
mean, once you turn it off, how do you turn it back on? Because you can't find where to move it on the... Because it's not on my little...
I thought it was on the touch bar.
I
know it's on the physical keyboard if you get a non-touch bar model.
Yeah, well, you can configure your touch bar, so I don't have it on my... Well...
When you first boot up, like when you're at the login screen, is it
maybe
not?
At that point.
I would imagine it's on there. And I'm sure he went with the touch bar model because it was the more expensive unit, and they only come with touch bar.
You don't have an option.
Yeah. So and I think they're moving that way. They're phasing out the physical keyboard one, or the regular, function key one.
Yeah.
But what's interesting here is how they replaced the motherboard and they replaced the screen. But Macs actually store their settings. They store it on the physical board, but they also store it in software. So unless you reformat and reinstall, it remembers that the screen brightness is turned down. That's why they were able to change out that hardware and the settings stayed. I've seen that on non-Macs, just on like Windows machines. Windows doesn't store it, but some vendors, Toshiba was really bad about storing that in software as well.
Well, that is embarrassing.
Yep.
That's no good. All right, well, we do have an interview to get to, so let's go ahead and do that now. We've got John Prisco, who's the CEO and president of QuantumXC, and Don, they're doing something a little unique with basically how we're doing encryption, right, and how we're passing the key.
When you encrypt data, right? So you've got your encrypted data, but you've got to securely exchange keys somehow between you and the recipient so they can decode it. And that's a sensitive operation. That's why we have these Diffie-Hellman key exchanges and other things that try and take care of that in very complex methods. Well, there's a huge risk out there right now that if quantum computers become a regular thing, that they'll be able to break our current encryption pretty easily. Well, implementing quantum computers to do encryption is still a very expensive and very arduous process. What QuantumXC does is they say, look, just leave your data encrypted the same way, but you can actually use quantum technologies, not quantum computers, but the quantum technologies to transmit your keys super secure. And that in turn will make your traditional encryption far more secure because the keys that are secure, and it's the keys that are really sensitive anyway, so it's neat. I'm curious to talk to him to see how all that works, because in my mind, I understand the concept, but I don't understand how you would deploy that. So I want to hear from him how that works, and hopefully he'll be willing to share some details with us.
Well, then what are we waiting for? Let's get to it. So let's talk to John Prisco from QuantumXC, but we're going to do that right after this on Technado.
I'm James Packer. I'm the General Manager of Kirk ISS based in the Cayman Islands. I used IT Pro TV extensively in my last place. It grew very well, helped upskill the team. I had 110 engineers in the field and we had dozens of IT Pro accounts with the guys training, and last year alone they passed over 40 certs by using the online training. I think I can safely say without IT Pro TV I wouldn't be where I was today, because I only got this job on the back of the qualifications I have.
Hello and welcome back to Technado. And as promised, now we're joined by John Prisco, all the way from Bethesda, Maryland. Now, John is the CEO of QuantumXC's. John, how are you doing today?
I'm good. How are you?
We're doing great here. Thank you. So for those that aren't familiar with QuantumXC, can you give us a little background about who the company is, what you guys do?
Sure. So we're the first quantum communications network in the United States. And this is a commercial fiber optic network that transmits quantum keys over the fiber, currently between Boston and Washington, D.C., and we have a metropolitan area network in the New York metropolitan area.
So do you guys physically manage that network, and that's your infrastructure, or is it just the software that's going on behind the scenes?
No, we do manage the infrastructure, and the service is provided by us end to end. And this is all around trying to future-proof encryption and prevent quantum computers from being able to decrypt secret keys that are used for encryption and decryption of very sensitive data.
Now, this is a problem we've been hearing about a lot lately, that quantum computers will basically just be able to make a laughingstock out of some of the current encryption protocols that we use. Not many people have been able to quantify for us, though, like how long do we have before that hits critical mass? Like, are we already in a danger zone?
Well, we are in a danger zone because nefarious actors are harvesting data every day. And what they're doing is they're stealing data, and they're stealing the classical encryption keys that go along with that data. So quantum computers today are not able to break the classical keys yet, but they can store the data and the key. And when the quantum computer is available that is powerful enough to break the key, then they'll be able to read any sensitive document that they've stolen. So, we've got this problem right now every day, and there is one way to prevent that from happening, and that's by actually using a quantum key in combination with a classical key.
So this is an interesting idea because from everything we've heard, like, quantum computers are still a very, very cutting edge technology. I know there's still some arguments over whether some of the quantum computers in use are even count as a quantum computer. So in this case, you're not saying it's a total replacement for what we're already using. It's kind of supplementing it. And can you explain how that's useful? Like, why would I just want to use a quantum key and leave the regular encryption with the traditional stuff?
Well, because a classical key is just the product of two very large prime numbers. And in order to break the key, you have to factor that large number into those two primes. It's pretty difficult to do. But historically, it has happened. And in fact, 128-bit keys and 256 and 512 have all been broken. The largest key that's ever been broken is 765 digits big. So what we use today is RSA 2048, 2048 digits wide. It would take a current computer about a billion years to factor that and break the key. Now, a quantum computer that's powerful enough would be able to do that in about 8 minutes. Now, we're a ways away, perhaps 5-10 years before quantum computers are powerful enough to do it. But given the investment made by Microsoft and Google and IBM and all of China and Russia, they're coming. It's not a matter of if, it's a matter of when. Now, a quantum key differs quite a bit from a classical key. A quantum key is made of light. So it is a series of photons that are encoded with ones and zeros. And in order for those photons to be intercepted, you would actually destroy the quantum state and the key would no longer be useful. So a quantum key relies on a law of physics. It's the uncertainty principle. You can't actually touch the key or try to observe it or steal it, because it'll lose its quantum state and the ones and zeros will no longer be the correct ones and zeros needed to decrypt the information. A classical key is really just protected by solving a difficult math problem. So having a quantum key, is as reliable as gravity. This is a law of physics and you can't steal it.
I just want to do a quick public service announcement for those of our listeners who are driving in their cars right now. That ambulance is not behind you. I just want to make sure that the building is not on fire, John, and if you need to run out, it's fine. We can reschedule.
Of course, you would. It would have to happen now.
So I did want to ask, though, because you guys kind of alluded to this, and I thought I was just dumb, but which still could be the case. But how exactly are you defining quantum then? Because is it a fixed amount, like a fixed number that you have to get to be talking about quantum computing, or is this like 5G where it's like nebulous and we can call it quantum if it's exponentially better than what exists out there?
Well, first of all, we are not making a quantum computer, but the basic difference between a classical computer and a quantum computer is that a quantum computer uses light. It uses photons, and they're called qubits or quantum bits. And in fact, the reason why a quantum computer is so much more powerful than our current computers is that the photon can be a 1, it can be a 0, it can be a 1 and a 0, it can be something in between a 1 and a 0. That's called superposition. And because of that, the computer is able to do massively parallel operations that a typical computer that we use today cannot do. Now, for us, the reason why we call what we're doing quantum is because we are encoding ones and zeros onto photons. And, by polarization, for example, we can polarize a photon vertically or horizontally. The vertical could be a 1, the horizontal could be a 0. When we transmit that over fiber, it represents the key, a very secure key. And if someone like a man in the middle tries to intercept the key, they'll simply destroy the quantum state of the photons and the key won't be useful to them. So today, you can transmit very sensitive data with long shelf life that is encrypted with a quantum key. If somebody steals it, all they get is the data, the encrypted data, which cannot be decrypted without the key. So if you can't have the key, it doesn't matter if you stole the data. So this kind of a system future-proofs data that you're transmitting today, no matter when a quantum computer is available that can break the encryption. So it's something that should be used today.
Now, I'm curious about this because it in my mind, it opens up some new possibilities. The key, since it really can't be intercepted, you can transmit that right alongside the data, and that's done safely. On a traditional, like let's say a site-to-site VPN. So on a traditional VPN, if I'm trying to configure it securely, we have to have complex things like a Diffie-Hellman key exchange and all that to go on. We really wouldn't need that with your solution, right? It doesn't have to be securely exchanged since somebody can't even physically intercept it?
Well, actually, we are securely exchanging it. In fact, Whitfield Diffie is one of our advisors. So, we use the technology and the technique that he discovered. But the point is, if the key were stolen, it would be useless to the person who stole it. So we're all about securely transmitting the key, but the technique we use to guarantee that it's securely transmitted is this quantum key distribution technique.
Okay, now would would key lifetimes still be about the same as they were before then? Like, I know normally even on like a high security tunnel, we might set it where it rekeys every 60 minutes, right? Like a 1 hour lifetime. Sometimes 12 hours, just kind of depends on the security of the tunnel.
Right.
But since you're able to just quickly transmit it on the line, do you rekey more often, or is it less sensitive? What does that look like?
Well, we can key very often. In fact, it's quite usual that we can create a key every minute. So, and you can also buffer the keys and save them. You know, if you wanted to change keys frequently, you'd have 1,440 keys per day in a buffer that you could use whenever you'd like. But these keys are created quickly, they're transmitted quickly, and they really do resist any sort of denial of service attack or even a fiber cut. So it's a very secure system.
All right, now, unlike some of the other quantum solutions that we've interviewed over the last year, yours is an actual tangible product that is in use right now. I think you said it was in between Boston and DC. Is that correct?
Yeah.
Yes. Yeah, we have just about 1,000 kilometers of optical fiber, and we have a metropolitan area network in New York, which then spans the Hudson River, goes to New Jersey. Because a lot of financial services companies have back offices in New Jersey. But yeah, this is a real live operating commercial network. It's not a science project. It's not a physics laboratory project. And quantum keys are under the Hudson River right now.
And who's your target market right now? I know this is going to change as time goes on, but right now, who are you basically designing this for? What type of customer?
So anyone with sensitive data that has a long shelf life. So those verticals that would fit into that category are financial services companies. Certainly here where we're located in Bethesda, Maryland, the federal government, of course, has a great application for this. Of course, healthcare with all the PII that they're securing, and that, of course, is a very long shelf life. So any secure communication requirement with a long shelf life, and in fact, we're working on a use case now which would secure the transmission of election results, which will be, of course, in the news or is already in the news.
And yeah, that would certainly be a really big deal. Everybody's trying to get that perfect solution in there. Now, as you guys expand out, we mentioned the managed fiber, how you basically are controlling that network. In the future, are you going to be able to like bolt onto existing fiber networks, or is it always going to be we just kind of have to wait for your network to expand out?
Well, what we do is we buy dark fiber from existing fiber providers. And there is a lot of optical fiber in the United States. So we don't actually construct any of these networks. We buy fibers in existing routes, and we'll be expanding across the country, certainly into the Southwest, Midwest, and the West Coast. But for now, we're on the Northeast corridor between Boston and Washington with a metropolitan area network in New York.
I noticed he did not mention the Southeast. Are we not getting the fiber down here in Florida?
We'll get there.
We'll get there. Thank you.
Well, one big use I'm thinking of, and actually I guess it wouldn't be appropriate because this is fiber only. Let me back up a bit. This is fiber only, correct? Or am I making an assumption there?
Well, it is fiber only, but, for example, the Chinese launched the Mischius satellite, and they're bouncing free space laser beams off that satellite and transmitting quantum keys thousands of miles. And, that's certainly a technique that's been proven and can be done. Of course, it's a little problematic when it rains.
It's just like your satellite television.
Yeah, I'm sorry, you can't access your data today.
Your car keys are out.
We can't do that wire transfer for you. It's raining.
Well, what popped into my mind early on were the undersea cables, because they are huge targets for somebody potentially intercepting data. But I believe those are mostly copper, if not all copper. Are those?
No, they're really fiber. In fact, Huawei just reported that they were selling their undersea cable business, I believe, And, they were building and maintaining fiber undersea cables. So certainly would be like drinking from a fire hose if you would tap those fibers.
Now, let's say we were to put a project like that in front of you. Are you constrained by data rates or anything right now? I don't know necessarily how your hardware works that's generating the keys.
Well, quantum key distribution has a limitation in terms of the distance that the keys can travel, but we've been working on a project called Trusted Node that takes the keys that are basically dissipating, and that happens in about 100 kilometers. And it essentially takes a new quantum key and wraps it around the first key that's sort of been attenuated by the 100 kilometers of fiber. And it gives it a piggyback ride to the next 100 kilometers. And you do the same thing at that trusted node. So we've been able to, for example, it's about 850 kilometers between cable kilometers, I should say, between Boston and Washington. And we've been able to basically repeat the signal using this technique. And repeat's a bad word with quantum because you really can't handle the photons without destroying their state. The same thing that protects us against having someone steal the key makes it difficult for us to transmit the key or to retransmit the key. But this trusted node technology enables that. So for example, if you wanted to cross the ocean, you could do that. You would have to submerge a trusted node every 100 kilometers or so, maybe 150, and as the equipment gets better. But that is how we do it, and that's how we get past the distance limitation.
And is the trusted node something you've already constructed, or that's a project in the works?
It's something we already constructed, and it's intellectual property that we own and are deploying.
And I guess if you think about like the weakest link in a solution, the trusted node, well, it would be considered weak, I suppose, because you are actually exposing the key for a brief moment. So I imagine there's a lot of security research that has to go in to make sure that is a trusted node, right? I guess that's where the name comes from.
Right. Well, exactly. Well, when you look at the way things are done today with fiber optic cables, every inch of a fiber cable is susceptible to being tapped. So if I tap a fiber, I can take 10% of the light out of the fiber easily with a very inexpensive device. And basically, I can receive all of the information that's going over that fiber. So what we've done is we've limited that now to just a few points along the route, and those points are guarded. They are in secure facilities, and they also have a cryptographic boundary in the hardware that will basically zero out the keys if someone tried to pry the lid off of it, so to speak. And we're in the process right now of being certified by NIST for FIPS certification. So, it'll have the NIST Good Housekeeping seal of approval on it as well.
I was just about to ask about government applications because you mentioned financial institutions, and they certainly are transmitting sensitive data, especially between their production and their disaster recovery locations. That totally makes sense. Right. But I can see an absolute use for this in the U.S. government. Have you been working with them at all? Have they shown interest in the project?
Oh, definitely. So, of course, the Department of Defense and the intelligence community is very interested in this. They have the kind of secure communications requirements that this really does well with, and yes, there's a lot of interest in this field.
Now let's say we had a perfect environment here where like us here at Technado, where we had a specific need for the technology. You already had fiber in our yard, and so it was easy to get connected up. At the customer site, what does that connection look like? Is it just you terminate it to a network jack and everything else is invisible to us, or do we have to have specialized firewall or VPN concentrator or something like that to connect to it?
Well, it's a quantum key engine. It's hardware that we provide as part of the service. And it's a lot like any telecommunications gear, any lightwave gear. It would be hard for you to pick it out as something different if you were in a data center and you saw all the other lightwave gear. But it basically is a laser. It's a quantum random number generator so that the key material has the highest entropy. And it has a pulsing circuit so that the pulses are so narrow that only one photon at a time comes out of the laser. So that's how we encode the photon with polarization 1 or 0. And, we're sending millions of photons a second, but they are discrete. So they actually are sort of picosecond pulses, and the laser will spit out a photon at a time.
So then on the customer side, they have this device, which is similar to any other kind of WAN technology modem, I guess. And we're going to plug into that, and then we just see it as a invisible, like a layer 2 leg on the network. We run whatever protocol.
Yes. Yeah, that's right. So you don't really even have to change anything about the way you transmit your data. And you don't have to change your encryption either, because not all, but many of the encryption manufacturers, the encryptor manufacturers, have added a port that allows a quantum key to come into the encryptor. And that's another good indication that quantum key distribution is here to stay, because some of the largest encryptor manufacturers have made provision with a firmware upgrade to take the quantum key and combine it with their classical key. Now you have a hybrid key that's transmitted, but the part of it that can't be stolen is the quantum key, so the whole key becomes useless if it gets tampered with.
Now, I know this is really like cutting edge technology, so it's still evolving, but right now, is it all point to point between locations, or are you able to do multi-point networks?
So part of our trusted node invention includes the ability to do point to multi-point and hub spoke and mesh type networks. And that's really a very important step forward. Now if you wanted to have 20 buildings connected, you in the past would have to have 20 transmitters and 20 receivers. Now you can just pick an optimum location for a hub and then serve everybody with receivers from a single trusted node with this mesh capability.
The challenge with technologies like these, when I hear about them, so it sounds like an amazing product, and let's say we deploy that as our production line, then we've got to think about our backup. And how do you find a backup to this that would provide the same level of security? You'd really have a significantly weaker backup, wouldn't you?
Well, you'd have what you have today.
Right.
You basically would have what people are doing today, which is really susceptible to being stolen. But, you can build root diversity in the fiber links and have essentially a redundant network. And we do that in, certain high value routes.
Yeah, I guess you have to make a choice at that point that, if you transmit exclusively over QuantumXChange, you've got that level of security. The backup link, you'd have to decide, is it worth more to be online and less secure, or to be offline and totally secure and just let the network go down?
Right. Well, you won't be offline with us, because remember, we're just transmitting keys. We're not transmitting your data. You're transmitting your data the way you always did. So we can have multiple paths between point A and point B. And if, for example, a cable is cut, we just go to the other route. And again, we're transmitting keys only. So it's, it's different than a 5 nines kind of availability of the telecommunications network. But it is reliable.
Okay, so I might have misunderstood earlier then, because I thought we were transmitting the keys and the data over the same fiber. So what you're saying is we just separate it out, and now we can have any number of data routes. That's pretty impressive.
Yeah, in fact, the QuantumXChange network is basically a separate overlay network that doesn't get involved with your data at all. It just gets involved with transmitting the keys, and that's what makes it reliable and really a very good approach.
Yeah, that's I was talking about data rates earlier, but data rates don't necessarily matter there. You're just moving keys.
Yeah.
So it's
Right.
ingenious.
All right, so if I'm convinced now, I don't know about Don, but
You're going to get it in your home?
well, it's not in Florida yet. But
well, good
well,
point.
my Boston home, my place up at the Cape. So if I'm ready and I want to learn more about this, what's the best way to reach out to you guys?
Well, certainly you can take a look at our website, QuantumXC.com, and we'd be happy to talk to you.
Sounds good. All right. Well, thank you so much for taking the time to talk to us today. And Don, did you have any other questions before?
No, I'm good. I mean,
go?
it's really neat. I'm
Yeah.
looking forward to reading more about it.
Yeah, definitely. And I'm looking forward to kind of seeing this roll out nationwide, as you said. And I mean, the technology you were talking about with China is pretty cool as well. So looking forward to the future of this and seeing where it goes. But John, thank you so much for taking the time with us today. And we'll talk to you again soon. Sound good?
Well, thank you, and I enjoyed it.
All right. Thank you all of you for watching as well. But stay tuned because we've got more Technado coming up right after this.
My name is Dana Morrison. I'm the IT director at Grace Christian School in Raleigh, North Carolina. IT directors often hoard so much knowledge that it's hard for their team members to learn. IT Pro TV has given us the ability to level up our technicians to a point where they can decide this is important for me to learn. I would recommend IT Pro TV to any IT team. It's just a great tool for any IT professional.
Welcome back to Technado, and thanks to John for that interview and not making me feel dumb when he explained to me the difference between quantum computing and quantum stuff.
Quantum Leap.
Quantum Leap, yeah.
Yeah.
Yeah, it was Ziggy. And
We're doing an
Okay.
interview with Scott Bakula next
Oh,
week,
man.
and he'll explain the rest of this.
did he ever leap back? I can't remember how the show ended.
It ended with him going on to that terrible Star Trek series.
Yeah. That's very disappointing. Hey, we want to let you know about a couple of things happening here over at IT Pro TV. One that's starting today, and that's if you're watching this podcast on the day it comes out, which I'm sure you all immediately check it as you're just clicking refresh.
Stop what you're doing.
On iTunes, yeah. But this is happening the whole week of June 17th to June 21st. It's live week at IT Pro TV. If you head over to go.itpro.tv/live-week, you can see the whole schedule of events. We're doing a lot of cool challenges and game show kind of things and interviews and a lot of fun things happening. So go ahead and check that out. Even if you are not a member of IT Pro TV, you can sign up for a free membership and watch all that content live. And if you're not a member of IT Pro TV, well, I don't know what's going on with you because we've told you many times about a coupon code that we have for you at go.itpro.tv/Technado. We've got 30% off code for you to use, as well as 7-day free trials for you to check out, and demos for teams as well. If you have a team, we can get you hooked up there and see all the special features that are available just to you as a team. And finally, we've got the next webinar scheduled now. So at itpro.tv/webinars, the next one is When Disaster Strikes, an IT Pro's Guide to Disaster Planning. And Don, you're doing that with Mike. Are we talking about like natural disasters there, or just like any kind of disaster that would affect your systems? And your backups?
We're going to focus a lot on natural disasters, but also other events, like construction crane falling or something like that. Those are not natural disasters, but they certainly can impact our business. So what we're going to talk about a lot of those. Two different angles, two different webinars, one on long-term planning, one on short-term planning. It'll be a good time.
Sounds good. All right. Well, that is Thursday, July 11th, 2 p.m. Eastern Time, but you can register for it at itpro.tv/webinars. And even if you can't attend that time, go ahead and register because we'll send you the recording when it is available. We've also got all the old archived webinars, not old, the past webinars archived there as well for you to check out. So head over there. But well done. I think we...
this is my worst buzzword bingo showing yet. I barely...
You're close. You're missing... Oh, no.
I would need robotic and IoT. That's not going to happen.
That's not going to happen. And I would need 0 day, which I was very disappointed we didn't say in like 6 security stories, and microservice, which I believe is one of the words we're getting rid of now because it's just not happening. Yep. But I'll add software defined now.
Yes, I think software defined anything.
I don't know that we've said that as much as maybe you think we have, but maybe I'll find out that I just haven't been listening to you.
Yeah, it's the trending thing.
Also, a very real possibility. Well, we're gonna get Justin back next week, right? He'll be
probably
here when we film. Okay, If not, it worked out fine without him. But thank you so much, Don, for explaining all of that to us. And thank you, all of you, for watching. But we'll see you next week right here on Technado.